Hello my dear students. So today we will be discussing alcohols, phenols, ethers. Okay, so I have collected 15 important questions from the previous year papers. Okay, so using these 15 questions we will be covering this alcohols, phenols chapter. Okay, so now if you wanted to know more detailed information about this particular chapter, so just go through the playlist of this channel where I have discussed about these mechanisms involved in these reactions, what are the important concepts in alcohols, phenols, ether and haloalkanes, haloarenes chapter. I have already made sessions on it. Okay, so now in this session we will be looking into the previous year questions of it. Okay, so now let us begin the session, and before going to that I just wanted to inform you about our NEET 2026 long term program, which is specifically designed for those who are taking drop year, okay, and looking for a serious preparation and looking for best guidance. Yes, you can choose NEET World as your best option for your preparation. Okay, so now if you have wanted to know more detailed information about this long term batch, just contact to the mobile number provided in the description box. Okay, so now we already launched this batch and started from July 1st. Okay, so if you are wanted to join this, just contact to the mobile number without doing any further delays. Okay, so let's begin the session. Yeah, so here we have a question here. See, I will be discussing it with more clearly. Just follow the class with full of patience and concentration. Look at this. The products AB obtained in the following reactions respectively are. So there are four reactions. There is a reaction given here. Two reactions are given. We need to identify this A, B in these given reactions. Okay. So now how can we do this? See, 3 alcohols, 3 ROH is given, treated with PCl3. Okay, so 1 mole of PCl3 is taken. So what is the product formed here? So 3 moles of alkyl chlorides are formed. So along with that, what is the byproduct formed here is a question asking. So just look at the structure of this PCl3 first. Yeah, it will be like this now. Yeah. So now we know chlorine atom is having more electronegativity. So therefore chlorine will goes out along with the bond right now. For every substitution, now remove the chlorine and substitute this OH group. Like that, how many OH groups will be coming here? So 3 chlorines removed, therefore 3 OH ions like this OH ion give to this, Cl minus give to this. This is the general tricky way to remember I am saying. Therefore what will be our product here? So our product will be H3PO3. So what is our product here? H3PO3 is our product, A. Okay, now in this case we know PCl5 having trigonal bipyramidal geometry, right? So trigonal bipyramidal geometry, we know phosphorus having 3 chlorine atoms in equatorial positions like this and 2 chlorine atoms along this axial, right now. So whenever PCl5 is heated or whenever PCl5 is participating in chemical reaction, there are 2 bonds which are weaker. Out of these pi bonds, 2 bonds are weaker. So those are, these axial bonds are weaker. Therefore, whenever it is participating in reaction, it will dissociate. It will releases this OH like this chlorine atoms from this axial position, this pink color which I have highlighted, because these are weaker bonds. Okay. So what is the product formed here? See, when it is treated with 1 RO like alcohol, so 1 chlorine atom is given to this. So therefore we are getting RCl. Okay. So remove this one. Therefore from this and remove this one. So we will be having PCl3 along with this. See, the OH group of this oxygen of this alcohol will be added to this. So we will be getting POCl3. Okay. So out of these 2 chlorines are removed. 1 chlorine is pairing up with this alcohol alkyl chloride, alcohol alkyl group. So it will becoming RCl, and 1 more chlorine is there now. So that chlorine and this hydrogen forms HCl. Okay. So this is what you need to remember. So we got RCl, HCl, and B is our POCl3. Okay, so this is how you can remember. Okay, so I explained it in the tricky way, not with the mechanisms. Okay, exact mechanism. Yeah, so Athar, I hope you are following it. It's clear, right? So how can you remember? Whenever you are seeing PCl3, just exchange these chloride ions with the alcohol, respect to alcohol. Therefore, what will be getting this alcohol converts into alkyl chloride, okay, and 3Cl minus I told you to remove and exchange with this OH. So you can write POH thrice directly, but in the options it will not be like this. So the structure will be different. So therefore you can write it in the oxo acid form of POCl3. I mean HPO3, you can write in this manner. This is the perfect representation of the structure. Similarly for this, what is our B here? POCl3 will be our answer. Right now, hope it is clear, right? So now what are the options? A, B, C, H3PO3 and POCl3 is our answer for this question, right? Yes. Let's move further. Yeah. So here we have one more question. Yeah. Look into this. Yeah. So if you look this, they have given reaction up to here, complete reaction is given, but they are asking what is the mechanism or what is the name of the reaction involved in this process. This is what they are asking. So how do we identify? See, just look, whenever you are doing organic reaction, first of all try to identify what are the electron deficient site, what are the electron rich site, or in other manner I can say what are the reactive sites we have, you need to identify. See, the reagent given here is sodium hydride, so Na plus H minus, hydride ion is there. So now hydride ion is a reactive reagent here. So now it can act as either nucleophile or either base. These are the two possibilities are there. Now in this compound there is no electrophilic site if I talk, okay, but it can abstract this proton. Therefore I can consider this H minus is acting as a base here. So H minus is a strong base abstracting this proton from here. So what is the negative part of it? I am saying this is proton is abstracted. So what is the negative part of it? So we will be having O minus as our negative part. Right now alkoxide ion we have. So this alkoxide ion and sodium plus sodium alkoxide ion we have like this. Hope it is clear. Now this is having oxide ion, like this is a negative charge. So can I consider this again as a nucleophile? Yes, that is also a nucleophile. Electron rich site is there here, O minus. Okay. Now here we have methyl iodide as a reagent they have mentioned. Now in this methyl iodide we know this carbon iodide ion bond is weaker because of a more electronegativity of iodine atom. This is one reason, but the exact reason we can say, so size difference between carbon and iodine is very large difference is there now, because iodine size is larger and it is a little more electronegative than the carbon. Therefore the bonded electrons will be taken by the iodide ion. Therefore it is creating positive charge on this carbon. Methyl carbocation is what we are expecting from there. That is the electron deficient site. So this is electron deficient site, this is electron rich site. Right now, so this electron rich site I can say nucleophile is going and attacking on this electron deficient methyl group. Therefore, what is our final product? See here methyl they mentioned it as Me, that is nothing but CH3 group. So this complete nucleophile is this part attacked on this methyl group. So this is our product. So this is how you need to understand the mechanism. Now what kind of reaction? See here iodide ion is replaced by this alkoxide ion, right now. So one negative charge species, one nucleophile is replaced by another nucleophile. So can we say it is substitution reaction? Yes. So what kind of substitution? One nucleophile replaced by another. So nucleophilic substitution reaction it is. Okay. So now the name of this reaction is what? Williamson ether synthesis, because what is our product? ROR. Ether is prepared now. Yeah. So preparation of this ethers using SN2 reaction mechanism is given by Williamson. So that's why we are saying it as Williamson's ether synthesis. See, Williamson's ether synthesis. Williamson's ether synthesis is our perfect name of this reaction. See, Williamson alcohols. No, these are not alcohol. This is ether prepared. So Williamson ether synthesis is the perfect answer for this question. Hope it is also clear, right? If it is clear, just click on the like button first. Yeah. So what is the mechanism involved in the Williamson ether synthesis? SN2 reaction mechanism you should answer. Hope it is clear. Now let's move forward. Yeah. So I hope you are able to see this. Yeah. If not, so just if you are able to see this, just give a try. Okay, I am moving forward. Yeah, so let us discuss about this reaction. Yeah, everyone who is studying class 12th or preparing for JEE and NEET, you should know what kind of reaction it is. What is the name of this reaction? Very, 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 very important reaction for your boards, for your all the entrance exams. So what is the mechanism? Tell me. See, phenols chloroform in basic medium forming this compound. What is the name of this compound? Salicylaldehyde. See, aldehyde is there, phenolic group is there here, right now. So salicylaldehyde is the name of the product. Okay, since it is salt of that salicylaldehyde, so we can say orthosalicylate, sodium orthosalicylate, we can call it as like that. So what is the name of the reaction? So it is called as Riemann-Tiemann reaction. Riemann-Tiemann reaction. So what happens in Riemann-Tiemann reaction? So this chloroform first of all react with this alkaline medium, I mean OH minus, forms what? Dichlorocarbene, CCl2. CCl2 is our electrophile in this reaction. So carbene, dichlorocarbene is our electrophile. Okay, so how this is generated? See, we have chlorine atoms like this on the chloroform like this, we have H plus. Now base, upon treating with this base OH minus, okay, this will abstract this acidic proton from here and gives us C minus CCl3 like this. Okay, so now from the same position, since chlorine atom is more electronegative, so that will take the electron density from the chlorine, from that sigma bond towards it. So we are removing minus Cl. Therefore what we have? So in one orbital we have these electrons, so I am representing it with negative charge, and one empty orbital is created. So it will be like this. Okay, so it is having now 6 electrons only on the carbon. So that's why we are calling it as dichlorocarbene as a electrophile. What is this? Electrophile. Okay, so what is the electrophile involved in the Riemann-Tiemann reaction? You should say CCl2, that is what? DCC, dichlorocarbene, in the short form DCC is our electrophile. So where do we have option? See, dichlorocarbene. This is the answer for this particular question. Okay, so now, so this is the electrophile. We know phenol is an ring activating group, alcohol is there here, OH group. So it activates the ring at ortho position, negative charge is at ortho and para. Therefore this electrophile, which is electron deficient, can attack at this electron rich site of the benzene ring or the phenolic ring or the para position. If it is at ortho position, so this will be the major product. Okay, and if it is at para position, we will be getting phenol here and here CHO. So this is para product, this is ortho product. But ortho product is major because the OH group at this ortho and aldehyde group this oxygen will be having intramolecular hydrogen bonding, that makes it to be the major product. Okay, stabilizing product. Hope this is also clear. Yes, if it is clear, just click on the subscribe button, and also just feel free to express your feedback in the chat box. I am looking into it. Yes, you can express whether you are able to follow. If not, how can I help you? Just write it, feel free to discuss. Yeah, next. Which among the following will be most readily dehydrated under acidic condition? Yes, tell me, which among the following is dehydrated most readily under acidic condition? Yes, so will you give a try for this? So first add hydrogen H plus ion to that and remove OH minus. That should generate more stable carbocation right now. So after that we will get elimination reaction, means we will get alkene as a product now. So based on that concept, you just give a try. If not, I will be explaining that in the next class. Okay, so just take a screenshot and give a try for this. Yeah, so again whatever we have discussed for the first question, I told you now, PCl3 I have taken PCl3 with alcohol. Yes, PCl3 with alcohol we have taken and we did this. PCl3 with alcohol we have treated, we got some product, and byproduct I told you that PH3PO3 as byproduct in that case. So here instead of having chlorine, here we have bromine. So what you need to do, remove this OH group, replace that with a bromine, so that we will get what, Br here, I am writing Br, and here methyl group, this is our EA, okay. So this is our byproduct, okay. So this has to be treated with alcoholic KOH under heating condition. So under heating condition, what happens under heating condition with base? So base abstract acidic proton, see the bromine containing carbon is alpha carbon and this side carbon, adjacent carbons are beta carbons, okay. Now you need to remove one proton, from that we should get a double bond like this, and what is our B here? So we will be having methyl group over here and double bond like this, okay. This side also beta proton is there now, so that can also be removed, so you will get a product like this, CH3 group here and double bond here. So out of these two, they are saying major product. So which alkene is more stable? We know internal alkenes are more stable, or I can say double bond containing carbon should contain alkyl groups. Why alkyl groups? Because it is an application of hyperconjugation where we are learning that more the number of alpha hydrogens, more will be the hyperconjugative structures with this double bond and more is its stability. So this is the reason that internal alkenes are more, substituted alkene is formed as a major product because it is more stable, okay. So this alkene is major, okay, this is our product here and this is our minor. Why I am saying this is minor amount formed? Because it is less substituted. See this side we have hydrogen, only one alkyl group here, another alkyl group here containing two alpha hydrogens with respect to this double bond, and here one alpha hydrogen with respect to this double bond. So it should contain more number of alpha hydrogen with respect to these double bonds. See the alpha carbon means the adjacent carbon attached to this double bond. This is adjacent carbon. How many? 3 alpha hydrogens. Here 2 alpha hydrogen. This is also alpha. And this side 1 hydrogen. This is again alpha carbon. So how many? 3 plus 2, 5 plus 1, 6 alpha hydrogens are there here. So that's why this having more number of alpha hydrogen, more is a stability. So this will be the B formed as a major. So what is our answers here? So you can go with, see this and see this we got A as like this and B as like this. So this is our perfect answer for this question. Hope it is also clear now? Yes, it is clear, I hope. Right now? Now let me give you one homework question. Yeah. So tell me what is the product B here in this reaction, okay. So now I am writing this same reaction with the HBr, okay. So what is the product formed here also, and I am treating this with SOCl2 D. So what is this ABCD products? Just simple reactions these are. So just tell me the answer in the chat box, okay, or you can join our Telegram group. You can just post your answer there. So I will be looking into it whether it is correct or not. If it is correct, it's well. If it is not, I will explain you what is the exact answer for this, okay. So you can join our Telegram group, link is in the description box, okay. So now, yes, Abdul, I hope you are listening to the class. Yeah, so your correct answer only, yes. Let's move forward. So just answer this question either directly in the chat box or in the Telegram group. You can join and you can give your answers, okay. So I will be looking into it, no issues, okay. Let's move forward. Yeah, so tell me what is the acidic nature of these 4 phenols, which is more acidic, which is less acidic, give the order of them. Yes, I will be looking into chat box. Tell me Anyone in the comment box can write your answer. Yeah, so look into it. So phenols are there. We know acidic nature of phenol means this is a phenol given. So what is the acidic proton? Here we have acidic hydrogen, is this one is the acidic hydrogen right now for the phenol. So now if it is released, the ease of release of H plus ion from this particular phenol will makes it more acidic. Right now more easy to release, more is the its acidic nature. Now this is the phenoxide ion. If this phenoxide ion is more stable, then this phenol will be more acidic. So now this phenoxide ion is containing negative charge now. So this negative charge has to be stabilized by this conjugation, then that can be more stabilized. I can say respective phenol is more acidic. Okay, so in order to stabilize this phenoxide ion, there should contain at least one electron withdrawing group either at para position or at ortho position, that makes it to be more stabilized by dragging this negative charge electrons towards the electron withdrawing group. Okay, so now here we have nitro group at para, here at meta, these are electron withdrawing groups, strong electron withdrawing groups. So here we have methyl group, this is electron releasing group. What I told you, so phenoxide ion is stabilized more when electron withdrawing group is present. Therefore I can say electron withdrawing groups containing phenols are more acidic because respective phenoxide ion is more stabilized. Okay, so now out of these four, I can say this is containing nitro group at para position, that negative charge is stabilized by electron withdrawing group by mesomeric effect, minus M effect. Therefore fourth option is more acidic. See, we have nitro group, but that is at meta position. If it is at ortho para, we know that will be stabilizing by minus M effect, but we know minus M effect will not work at meta position, only mesomeric effect, inductive effect will be working here. So minus I effect is there here. So I can say this is minus M effect, therefore this group should be having more effective withdrawing nature, therefore that will be more acidic. After that 3 electron withdrawing group. See, when I say electron withdrawing group containing compounds phenols are more acidic, the reverse of that electron releasing group is there. So electron releasing group containing phenols are very less acidic. So here it is less acidic than all the given options because here nothing is there. So nothing is better than this electron releasing group. Therefore I can write here 1. Okay, so this is our option. So choose the option which is containing this kind of order. See, option number 4 having this order. Yes, so this is your answer. Yes, yes, those who are in the chat box, yes, you are doing really well, your answers are also correct. Yeah, so if you like this explanation, just click on the like button first. Yeah, so if you are new to this channel, do not forget to subscribe the channel because every day I will be coming live. Okay, so at 12:30 I will be live with the same questionnaire sessions. Okay, okay, so every day at 12:30 I will be live with the questionnaire sessions. I mean I will be bringing few questions of JEE, NEET, PYQs which are quality PYQs. Okay, it's not like random PYQs. I will be bringing few selected PYQs. Okay, and again evening at 7 p.m. 7 to 7:30 I will be live. Okay, so where I will be covering during that time, I will be covering important topics. I mean, for example, electrochemistry if I discuss. So from that, what are the important topics we have? So like electrolysis, like electrochemical cells, then next Nernst equation based questions like this. So I have covered electrochemistry in the evening live sessions. If you haven't watched, you can watch or you can join everyday live. So today I will be coming live at 7 o'clock again. So where I will be discussing solutions chapter. Okay, solutions from class 12th. Okay, if you are seriously preparing, come do join the live session. We'll like make our preparation to the next level. We'll take our preparation to the next level. Okay, so feel free to express your concerns in the chat box. I will discuss. Yes, let's move forward. Yeah, so this is the compound given, suitable reactants for the following ether formation. So this ether has to be formed. So for preparation of this, what is a suitable answer? Yes, anyone in the chat box? Anyone in the chat box can answer this. Yes, thank you Abdul. Yeah, I hope you are following the class effectively. Yes, so tell me, anyone in the chat box give a try to answer this? Yeah, so how do we do? Look here, always remember, I will give you a simple explanation for this. See, if you break the bond over here, we will be having, see, why I am breaking, how to give the approach for this question. First of all, listen here. So we require two phenyl groups should be there, between that this group should be there. So now, definitely, there should be methyl group attached to the one of the group. So see here, we have phenyl group is there, but CH2 group is absent in this case. So definitely this option is incorrect, remove it. Okay, next go through the remaining two options. Now here, yes, this part is there, okay, it means this part is there. So this part, let us say here we have. Again, here in this option, yes, this part is there, it means CH2 and phenyl ring is there. Here also we have this part. So these two options are having. Now we have confusion between these two options. We need to choose only one answer as correct one. So how do we do this? How do we do this? Look here, see, I am breaking the bonds. See, this is what I can say, retro method I can say. So now you just try to break this bond this side, because between carbon and oxygen, which is electronegative, we know oxygen is electronegative, so it will take this bonded electrons with itself, right now. So just give a try, break it and take the like what are the parts we have. So phenyl group we have, so with the positive charge on that phenyl group. What is the other part we have? We have benzene ring here having methyl group having O minus charge on it by breaking this. This is what we have, the two parts. Now what if I break this side, if I break this bond, what is the other possibility by breaking this side? Because oxygen only take the bonded electrons, so oxygen should have negative charge. Methyl group, this methylene group should have positive charge. So I am writing that methylene group with the positive charge like this, and oxygen now in this case attached to the benzene ring, na? Take like this. So these are the two things we have. Out of these two, which is more stable species here? See, phenyl carbocation is highly unstable, because aromatic ring here previously now having positive charge, which is highly unstable. So this kind of breakage won't happen. Okay, so this is the only possible breakage we have. So now what I am taking is, I am converting this phenoxide ion like a benzene O minus Na plus. This is the one species I am taking, and this one I am taking. See, this carbocation is highly stabilized by this ring pi electrons by resonance, right now, mesomeric effect. So if you don't know mesomeric effect, inductive effect, hyperconjugation, just go to the playlist. It like almost 45 days back I have already explained these GOC concepts. You can watch it, it will be in the playlist. Okay, so now this will be stabilized by the conjugation of these pi electrons. Therefore I am taking these two species, so CH2, and here put the halogen like X. This X goes out, will give this carbocation, benzylic carbocation. So these are the two parts we have. Okay, so now take benzyl halide. See, benzyl halide is here. So benzyl halide is here. See, CH2X, and phenoxide sodium, phenoxide ion is here. So this is a perfect answer, not the second one. Hope this is clear. So what you need to remember, these compounds like phenyl halides, directly if we have like this, they do not involve in substitution reaction. Remember this. Phenoxide ions do not this benzyl halides like benzene, phenyl halides I can say. Phenyl halides do not involve in what? Substitution reaction, because it is highly unstable if we remove this halogen from here. Hope this is clear right now? Yeah. So which option is perfect one? So option 3 will be perfect answer for this question. Yes, right. Let's move forward. With one last question, we'll wind up the session and we'll be coming back evening. Okay. So now look into this. Phenols can be distinguished from alcohols by, so what we need to do, phenol is like this, alcohol is something like this. So how can both our alcoholic group is present, OH group is present, but how can we distinguish this phenols and from this alcohols, with which reagent we can distinguish? So here when we treat with FeCl3, the phenol forms a complex but not alcohol. Okay, so phenol, upon treating with this neutral FeCl3, so it will form a complex of Fe. So I can write this as OPH. PH represent phenyl group, O represent this like OH of oxygen of OH. So I am writing OPH 6 times. So this kind of complex is formed. Okay, but not this alcohol. So what is a suitable reagent we need to use? Neutral FeCl, the ferric chloride is used. So for more detailed information, just look here. So litmus test for distinguishing of phenols and alcohols. See, litmus test, alcohols won't give test towards litmus test, but phenol converts blue litmus to red. So what I can say, phenols are showing acidic nature. Phenols are what? Showing acidic nature. From this you can explain. Now neutral FeCl3, just now previous question we have seen now here, this question is there now, concept you can look here. So now FeCl3 upon treating, alcohols do not showing any reaction towards this neutral FeCl3, but phenol is forming violet color complex. Okay, then next, benzene diazonium chloride or benzene diazonium salts, okay, salts do not react with this alcohols, but they will form dyes, azo dyes, when we treat it with this phenol. So forms yellow or orange azo dyes. So this is how you can distinguish. Next, with bromine water, alcohols no reaction, but it will forms, phenol forms like 1, 2, 3, 6 tribromophenol like this. If this is a phenol, okay, so the reaction upon treating with bromine water will get bromine over here, para, will get bromine over here, ortho, and this ortho. This is the product formed when we treat with bromine water, with phenol plus bromine water. Hope it is also clear. Yes, so take the screenshot of this and make a note of it properly, and you can join the session again in the evening. Yes, yes. So now anything to be discussed? Yes, feel free to tell me, feel free to discuss with me. Yes, so thank you for watching, those who are in the live session from the beginning. Yeah, so now again we will meet at 7 p.m. okay, and we will continue the topics related to these alcohols, phenols and ethers in the upcoming session. It means by tomorrow and day after tomorrow, okay, at the same time. If not tomorrow, day after tomorrow we will be discussing. Okay, so but we will complete these PYQs of these alcohols, phenols, ethers in the upcoming sessions at 12:30, and evening by today evening we will be discussing what? Solutions chapter. So stay connected with the channel. Now you will be having continuously, you will be having other subjects too. After me you might be having botany, bio subjects or physics for physics, and also mathematics for MPC students for JEE. Okay, so thank you for watching.